Hey guys, Wordy Nerd here, back with another video. Sorry I haven't posted in a long time. I got busy and I couldn't find the time to do it, but now I'm back. So today we'll be looking at gyro sensors. Gyro sensors are very important because they keep your robot accurate in FLL, which is very important. If your robot is off even by 1 degree, those degrees can stack up, and by the end of the program, your robot may be 25 degrees off. It's very important to make sure your robot is accurate, which is why today we will be learning about how to make sure your robot goes perfectly straight and turns to a correct angle every single time. Let's get started. First and foremost, before we get to anything about programming, we need to make sure we've mounted our gyro sensor properly. As you can see, this is my robot, but I have my gyro sensor mounted sideways. That really doesn't matter because even if you turn 90 degrees, the gyro sensor will still detect 90 degrees. This is also good because my robot is very vertical, yet this has a horizontal position. So I need to put my gyro sensor in a horizontal position to fit the robot. I have it in a very small space to make sure that it's stable. If your gyro sensor isn't stable, it won't be able to detect a correct angle, and that is very bad and destroying the point of using a gyro sensor, which is why it's very stable and I have many points of contact at the bottom. This is how I would recommend mounting a gyro sensor, but I've seen teams mount it on the side, and that's also okay. It just might be less compact, and if you're using a box robot, you might not be able to position it properly in all areas. Now let's get onto the programming of gyro straight and gyro turns. First off, we will start with our gyro straight program. This is a very simple program. It does not multitask, and it just simply goes to the end. In my next video, we will learn how to make this into a my block for ease of use. But first, we will just look at the beginning of this program. First, I start with my motor rotation blocks. As you can see, I have my motor ports as B and C, but you can switch this to the motor ports that you are using. And then I go down here and hit reset for both of them. You can find these in the sensor section. Then we will pull out a gyro sensor, and then we will hit reset with this one too. And you can select whatever port you are using for your gyro sensor. Next, we have this loop. This is the main portion of the program. First, we have a gyro sensor block, and then we will switch this to measure angle. And I am using port 1, but again, you can use whatever port your gyro sensor is plugged into. After we measure angle, we will take this input, and then we will plug it into A, in a multiplication math block, which can be found in variable operations. We will multiply this by -4. And then we'll plug whatever it equals in to the steering. I will explain how this all works later. We will set your power to whatever you need. I'm using 25, but you can switch it to whatever works for your needs. And then we'll put this all in a loop block. We'll switch it to motor rotation and degrees. And use one of your drive ports and plug it into here. I am using B because I'm using B and C. It really doesn't matter which one you use. Then you will go to greater than or equal to, and you can leave this blank for now. Again, I will go over all of this later. And then you will wait 0.3 seconds just to give the robot time to reset, like it does at the end of the actual motor block here, where you have a break time. So now I will go over this complicated loop. It really isn't that complicated, it just seems complicated in the beginning. If you walk it step by step, it will be simple. So first you want to measure the angle and multiply it by -4. This essentially is your robot sensitivity. If you change this to -10, it will make extremely great corrections when following a straight path. If you change it to -4, it will make slightly smaller corrections. For FLL, I recommend anything between -4 and -2. If you have larger wheels, I would recommend -2. If you have smaller wheels, I would recommend -4. Larger wheels can also use -3. Which is also good. I have experimented with that, and it is amazing. Then you will plug this into here, and this essentially will be steering your robot. I set it to 25 power for my small wheels, but you can set it to whatever you want. This is our main stopping block. You want to know when to stop and not have it drive in a straight line forever. I change it to greater than or equal to because there's a chance that the sensor won't detect it when the momentum is pushing the robot forward. This is set to however far you want to go. You can measure this with the ports in the robot brick when you are running your robot by a manual. So this is our block. and I will teach you in the next video I make how to make this into a my block for ease of use in FLL. Alright, so now let's look at our accurate gyro turn. This is much better than just turning with motors, and if you don't turn accurately, those few angles that mess up really stack up and your robot can end up being very inaccurate at the end. So, we use a gyro sensor to turn. Let's get started looking at the program. So in the first part of the program, we reset our gyro again. This is to make sure our gyro is accurate. Then, you put in whatever angle you want the gyro to turn into here. Let's say I wanted to turn 90 degrees. Alright, I put 90 degrees into here. And this is a math block that is dividing. Then we'll divide it by 2.5, and I'll explain why later. Whatever it equals to, we will plug into another loop block, which is a gyro angle comparison, which is greater than or equal to, and I will plug whatever this equals into here. I have my gyro in port 1 again, but you can set this to whatever port you need. And I would recommend setting a fast speed here. If you were using the large wheels, I would recommend using 30. If you're using small wheels, I would recommend using 40 or 45. Put one on negative and one on positive. I have it in ports B and C, so I will select that. Next, we will create another loop block, and now you will want to reverse your power. So if you had 40 on the left side and negative 40 on the right side, then you will switch your left side to a negative and your right side to a positive. If your right side was a positive, then you'll switch it to a negative. If your left side was a negative, then you'll switch it to a positive. But my left side was a positive, so I'll switch it to a negative, and vice versa for my right side. I will show you why later. Then, in this loop, we want another compare angle, and then we will have it in port 1 again, or whatever port your gyro is in, and then we'll put it equal to whatever angle you have. In the next video about gyros, I will also show you how to make this in my block to make everything easier for you in programming. Now, the way this works is, you divide whatever angle you want by 2.5. Then you plug it into here. The reason for the fast speed is so the robot can turn very quickly. But the momentum will most likely carry it over whatever angle you want. So then what you want to do is you want to turn the other way. And now you're going to turn very slowly until it's equal to 90. This allows for a very fast turn, but also a very accurate one because you go back. If you find that 2.5 isn't enough, you could use 2 or 1.5. All you need to do is make sure that when it turns, the momentum carries it over the angle, but it also turns very fast. This makes it very efficient. I hope you learned something from this video, and let's see the robot perform these two tasks, starting with the gyro straight. Sometimes the previous gyro turn program won't work, so if it doesn't, I would recommend using this. This has a calibration program in the beginning, credit to Builder35 for this, and then it will measure the angle and put it in and divide it by 2.6, similar to the last one. It will do the usual things, but instead of using momentum to carry it over and then going back, it will simply slow down to create a precise angle at the end. If your program isn't working, then I would recommend using this one for your robot. All of this will seem much easier in the next video when I teach you how to make my blocks out of this. That way you can make an accurate turn all in one block with parameters that you can adjust by yourself. If you have any problems using either of these programs, let me know in the comments and I will be happy to help you troubleshoot the program. I want this to work for all people, and if you have problems, feel free to let me know in the comments.